Good morning, and thank you for your time to discuss an important shift in how we measure the financial impact of our people here at Apex Coding Solutions. As your new HR director, I know that to effectively scale this 50-person startup, you need more than just HR intuition. You need quantifiable metrics. Today, I am proposing a new analytics-based HR system grounded in the methodologies of Casio, Boudreaux, and Fink. I will introduce our foundational data framework and then detail three specific high impact analytical methods we will use to measure and improve our organization's financial performance through our talent. Before diving into the specific metrics, we must establish how we treat data. I'm proposing we ground our entire HR strategy in the LAMP framework: logic, analytics, measures, and process, developed by the researchers Casio, Boudreaux, and Fink. Historically, HR focuses on the measures pillar alone, counting things like headcount or training hours. But as the authors argue in their book titled Investing in People, traditional HR measurement fails because it stops at counting. They explicitly state that a true measurement system must, quote, drive strategic change and organizational effectiveness. To achieve that here at Apex Coding Solutions, we need logic to connect our HR data directly to our strategic goals, like software deployment speed. We then apply analytics to draw the right conclusions and build predictive models. We do ensure that our measures are mathematically valid. And finally, process ensures this data doesn't just sit in a dashboard. It is actively used to influence our executive decisions. By anchoring our strategy in this evidence-based framework, we ensure that every metric I show you today is mathematically linked to our financial success. So the first metric we will deploy is the financial cost of employee turnover. At a 50-person startup, losing a single software engineer is a 2% reduction in our total workforce. However, simply reporting a turnover rate tells us nothing about the financial damage. Using Casio, Boudreaux, and Fink's methodology, we will calculate the actual dollar impact of turnover. We will measure this whenever an employee exits. The calculation involves adding our separation costs, such as exit interviews, administrative time, etc., replacement costs, recruitment, marketing, interviewing time, and so on, and training costs, onboarding, and lost productivity during ramp up. But here is where the analytics get advanced. We will adjust this cost based on performance differences. If a low performing developer leaves and we hire a high performing replacement, that turnover might actually yield a net financial gain. Casio, Boudreaux, and Fink refer to this as functional turnover. Conversely, losing a top performer is dysfunctional turnover and costs us exponentially more. By quantifying exactly how much losing top talent costs us, we can logically justify targeted retention bonuses and competitive compensation packages, proving that retaining top talent is cheaper than replacing them. The second analytical method focuses on the front door, or how we hire people. To scale Apex Coding Solutions effectively, we must ensure that we are hiring elite talent. To measure this, we will use a utility analysis of selection programs, specifically the Brogden-Cronbach-Lesser model, again introduced to us by Casio, Boudreaux, and Fink. So this sounds highly academic, and yeah, the formula on this screen may look intimidating, but it is simply a practical way to calculate the exact financial return on investment of using better hiring tools. Right now, if we only use unstructured interviews, our predictive validity is very low. I propose we invest in scientifically validated cognitive and coding assessments. How will we prove this investment is worth it? Well, let's go ahead and dive into this formula. We calculate the change in utility represented by delta U in this formula. This is the net financial gain that a new test will generate for the company. To find our delta U, we factor in the number of people hired, N, their tenure, T, and the cost of the new testing program, C. But the variables that drive the real financial value are represented by R sub xy, the predictive validity of our new assessment, SD sub y, the massive difference in dollar value between an average developer and an elite one, and Z sub x, which represents our selectivity. Z sub x is the average standardized test score of the candidates we actually hire. Because we only want to hire the absolute top tier talent, our Z sub x value will therefore be very high as well. By multiplying our high selectivity, Z sub x, by the high financial impact of our top developers, SD sub y, I will be able to show you exactly how spending a few extra $1,000s up front on the valid selection process yields a utility change of hundreds of thousands of dollars in enhanced productivity. To show you how this formula works in practice, let's look at a real-world scenario for Apex Coding Solutions. Let's say we need to hire 5 new software engineers this year, and we expect them to stay with us for an average of 3 years. If we invest $10,000 in a premium, scientifically validated coding and cognitive assessment platform, our predictive validity, or the R sub XY, jumps to 0.5. Because we only hire the best, our selectivity, or Z sub X, is a high 1.5, which means we hire the top 15% of applicants. Finally, based on our HR financial models, the value difference between an average engineer and an elite one is conservatively $50,000 a year. That is our SD sub Y. When we run those numbers, the gross value added to the company by hiring these elite performers over average ones is $562,500 over their tenure. We subtract the $10,000 that it costs us to buy the testing software, leaving us with a delta U, a net financial gain here, of $552,500. This is how we will prove that an HR request for $10,000 testing budget is not just an administrative expense. It's an investment that yields over $500,000 in enhanced software productivity. Our third method involves monetizing employee attitudes. Often, culture and engagement are viewed as soft HR metrics. However, Cassio, Boudreaux, and Fink argue that attitudes are leading indicators of financial outcomes. So we will implement quarterly pulse-style attitude surveys, measuring satisfaction with leadership, compensation, and the work itself. But we will not stop at just reporting a satisfaction score. We will calculate the financial impact using statistical regression. We will map the changes in attitude scores against hard business behaviors, specifically our software sprint completion rates, bug frequency, and our previously discussed turnover costs. If we find that a 1-point drop in engagement correlates with a 5% increase in the probability of developer turnover, we can immediately assign a dollar value to that drop in engagement based on our turnover cost calculations. This allows us to treat employee engagement not as a moral issue, but as a risk management and operational efficiency metric. We will calculate and present this correlation to the executive team semi-annually. As you can see in this regression model of our last 15 sprints, there is a distinct measurable correlation. Our chart indicates a highly predictable relationship. For every 5-point drop in our engagement score, we see a corresponding drop in software deployment. This proves engagement isn't just a moral metric, it is a leading indicator of our software output. So in conclusion, by implementing these 3 methods, turnover costing, selection utility analysis, and attitude monetization, guided by the LAMP framework, HR will no longer be a cost center. We will be a strategic partner capable of proving our return on investment. The implementation roadmap is organized by quarter. We will begin immediately in Q1 by baselining our turnover costs. This first phase establishes the cost of doing nothing, right? If we didn't do anything. By calculating turnover costs early, we set the financial baseline that justifies future retention spends. Phase 2 begins the implementation of the selection utility. This focuses on the front door. We will implement utility analysis and selective hiring tools such as cognitive coding tests mentioned earlier to ensure high return on investment hires. In phase 3, we will begin attitude regression modeling. This is the strategic link. It involves collecting enough data to mathematically connect employee engagement scores to actual software output. And then by phase 4, we will be prepared for an executive review and optimization of these operations. During this phase, I will present the year's wins and apply feedback to refine the system for next fiscal year. I look forward to using this data to help you and the rest of the team and the rest of the leadership team here make the best possible decisions for our company's future. Thank you again for your time, and I'll open the floor to any questions over the remainder of the session.